I'm Stephen Foskett, the organizer of Tech Field Day. We're here in Austin, Texas with Platform9 Systems. Around the table are a group of independent writers and speakers who specialize in enterprise technology. They've been brought in from around the world to ask questions and learn about this technology. To find out more about Tech Field Day, go to techfieldday.com. And to see more videos like this, go to youtube.com/techfieldday.
I'm Amrish Kapoor, and I lead engineering at Platform9. Prior to Platform9, I spent time at Microsoft delivering various virtualization product initiatives, including application virtualization and environment virtualization that formed part of Microsoft's desktop virtualization suite. For the rest of this presentation, we're going to keep the content brisk so that we have enough time to go through all of our demos. I know this audience likes a lot of demo time. We're going to spend time going over the last three evolutionary stages that Rupak laid out, starting with infrastructure as a service and Platform9's managed OpenStack product. In past sessions at Tech Field Day, we've covered how Platform9's managed OpenStack product can work across KVM and VMware hypervisors with a multi-region support. So I'm not going to spend too much time talking about that. We've already been introduced to the SaaS managed aspect of this through Rupak's brief primer. But what I'm going to spend time on is the enhancements we've made since then, not the least of which is extending OpenStack to also be able to manage public clouds. I'll spend a little bit of time talking about the motivations for us doing this. If you look at various OpenStack user surveys, time over time, they've made two main points. The main reasons users want to use OpenStack is because they want to standardize on an open public API, and they want to avoid vendor lock-in. As we worked with our customers over the last few years, we've heard this loud and clear, with an added wrinkle. Our customers are looking for exactly these same benefits, avoiding vendor lock-in and a public standardized open API, to also manage their public cloud resources. It's this realization that led us to contribute OpenStack Omni, which is essentially a set of drivers that plug into OpenStack that allow you to manage your corresponding public cloud counterparts. We introduced OpenStack Omni at the keynote in the Barcelona OpenStack Summit, and we've had a tremendous response, both from our customers as well as the community, bearing out our vision of essentially trying to standardize on an existing API layer instead of creating a new one from scratch. The obvious benefit from this is that organizations that have invested in OpenStack with tooling and automation around it can continue to use all of those benefits even across their public clouds. So this allows them to continue tapping into the rich ecosystem that OpenStack provides. And it's kind of a different take on the hybrid cloud model to solutions, the CMP solutions that you know of, like Scalar and Clicker and CloudForms, which create a completely new API that subsumes all the clouds under it. So this has the corresponding need for a ramp-up time to talk to that API and then create a new ecosystem around it instead of leveraging something that we already know works. In addition to Omni, we've also had a couple of other initiatives that we've open sourced to bring more enterprise hardened features to OpenStack. For those of you in the VMware community, you probably are used to seeing features like VMHA and lease management. So we built on the Masakari OpenStack framework to deliver both virtual machine high availability as well as application high availability to our OpenStack users. We contributed this back in August 2016. Similarly, we built Mors, our VM lease management component, and contributed that back in May 2016. We've gotten a lot of great feedback for our open source efforts, and our customers have derived great value from all of them. So really quickly, we'll jump into a demo right now. I'll hand off to Cody to go through some of these features, unless there are any questions that you have for me. All right, Cody?
Great. Yeah, so my name's Cody Hill. I'm the lead cloud architect the lead systems engineer at Platform9. In a previous life, I was the lead cloud architect at General Electric. Joined Platform9 about a year and a half ago, and it's been a roller coaster ride ever since. So I'm going to jump into a live environment here, and this one. And essentially, what I want to show you is kind of do a brief rundown of where we've been in the last couple Tech Field Days, kind of show you, get you familiar with our environment, some of the things we have in our UI, and then we'll jump into the live demos, emphasizing on the last few points that Amrish brought up around high availability inside of OpenStack, as well as public cloud integrations with Omni, and then showcasing that Moore's functionality. So a key construct here inside of OpenStack is the region selector, right? So this will be a differentiator between what data center you have geographically, or possibly the architecture underneath that data center. So if you're flipping between a VMware hypervisor versus KVM, those are stored in separate regions, as well as AWS would be in another region, right? So we have this region selector that you would get familiar with. And then we have multi-tenancy, right? So in all of those regions, you can then create a tenant, put them, give them a quota, and then you could switch from tenant to tenant if you have permissions to. And then you're locked into this environment that is, totally, multi-tenant. You could have Pepsi and Coke running side by side. They're unaware of each other, right? And so we have this, and then something else that we've added since our last Tech Field Day is this application catalog, right? So we've always had the Heat orchestration stack, the ability to create large orchestrated applications that consists of every component inside of OpenStack, right? You can create a network and routers and all these things and then deploy them as a large stack. But before, you had just a block of code that you had to execute, and it was a little goofy, right? So we've added this application catalog to make it really easy to publish these apps, and then you could deploy them, and they'll prompt you, right? So these are all the things that we're going to be jumping into showing this off, okay? So I'm going to flip over to our Tech Field Day DU, this is what we have up and running. We have two regions here. We have our San Jose core site data center, and then we have our US West Amazon data center that we're using as well. And then I'm inside of a Tech Field Day tenant here, right? So you can see this environment's pretty empty, right? I have some hosts, right? I have 4 hypervisors that are up and running here, but I don't have any virtual machines yet. I only have an external network, right, just to get out to the internet. I don't have anything else pre-created. And what I want to do is I want to launch an application stack. So I don't even have the application stack in here yet, right? So let's create a new application stack. We're going to call this our KVM app stack. And I'm actually going to pull this directly from that dirty code that we were talking about before, where I have about 160 lines or so of a YAML file that describes exactly how we're going to build our application, okay? You can check this into Git, version control it, all of that. So we're just going to simply paste this in here, choose a cool logo, right? So this application stack, in the end, will deploy an Apache server, so why not the Apache logo? And then we need to put this in a category, right? If you start getting hundreds of applications, you're going to want to be able to filter those by category. So this is a web app. We'll do that, make it public so everyone in our cloud can use it. And bam, we now have an application template that's ready to deploy. Okay? So let's go ahead and kick this off. So we're going to do a one-click deployment here. It's now going to prompt us for a bunch of values, right? This is how we can have this work on top of VMware, on top of KVM, on top of Amazon, right? So all of the APIs, all of the code is identical, but you need to choose your variables, right? So this is my external network for this region, right? External net 203. I'm using the CentOS 7.1 QCOW2 image. I'm going to be using my cloud SSH key, and I need to name this something, right? So how about KVM stack? So I have my KVM stack here. There's quite a few other options that we've set up. We're going to create a virtual private network with that IP space. We're going to call that network Murano Network. Murano is the name of the application catalog. And we'll go ahead and do a deploy here, okay? Now this deploy is going to take a little bit of time to deploy inside of our environment. You can see we now are in the environments view here. And it's going to go out and start creating a bunch of resources. So that's great. Let's do those exact same steps in Amazon. And please interrupt me, ask questions. I heard you guys were a lively audience that fires questions at people, so please do. So I'm going to jump over to the Amazon side of things. Before I do this, I just want to show you my Amazon VPC, right? So we're in Amazon here. We have virtually nothing in here, right? So I'm in the EC2 build. The only thing I've pre-seeded in this environment is a key. And you do that through OpenStack as well, right? So through Platform9, you come over to your access and security, upload an SSH key, and it'll push it over to Amazon for you. So that's the only thing I've preceded here to save a little bit of time. And then if we flip over to the VPC view, you can also see that this is going to be a completely empty, zero everything, across the board, empty environment. Okay? So let's do our application build. Let's come over here to the application section. Let's create a new application. We'll call this one the AWS stack. And again, same code, copy, paste. Choose our same little image here. And let's upload that application. And you could save these application stacks as zip files so you can upload them easily. You don't always have to copy and paste. But for the sake of showing you guys the code and that it is the same, I figured copying and pasting was a better demo. Great. So we have our application stack, same thing you've already seen. Let's go ahead and kick this guy off. So we'll kick off this one, this deployment. Again, the image now, notice the image name is changed. This dropdown will show only images that we see inside of Amazon. So this is an image that I had imported ahead of time into Amazon. It's using the public CentOS 7 marketplace image. This is not a customized image. It's just that public one. Again, the network, we pre-create the network for Amazon. Let me show you that before I deploy this. This is something that we pre-create for all of our customers, is the Amazon external network, right? And what that is a list of subnets that you might possibly get a public IP address from, okay? And these are all of the subnets that Amazon will deploy to. When you talk to Amazon's API, you can't say, hey, can I get a 52 dot address, right? They might give it to you, but you don't get to choose that. That's just what they do. So we precede this with all of the available blocks there. So now when I do this deployment, and I select my image, I select my public network, and we call this AWS stack. And I'll choose a T2 medium for my flavor, right? So these are now Amazon flavors that I'm showing in here, right? OpenStack has that same construct, but now I'm only able to see the ones that are in the availability zone that I'm in that this image is compatible with. And my SSH key that I seeded before, right? So the same variables, or same options we chose before. Let's go ahead and deploy this, okay? So we're in good shape there. This is going to be deployed. And I'm going to flip back over to the environment here and see how the deployment inside of KVM is going. And we're hoping for speed today so that we're not watching loading screens, right? Because that's never fun in a demo. Let's jump over here. Let's go to the instances section.
So hey, maybe I missed this, but where
Sure.
are you guys hosting your cloud?
So we host our control plane inside of Amazon Web Services.
Okay.
Right. So all of the bits for like the OpenStack schedulers and databases and APIs and all of that stuff that's kind of the heavy lifting when you set up OpenStack is hosted in Amazon, but all of the compute nodes are within your control, right? So whether you're wiring your own VMware vSphere environment or your own KVM nodes or your Amazon VPC, that's all of your compute behind your firewall. And we do all of that through an outbound HTTPS communication. So there's no VPNs to open up or set up or any of that.
Okay.
Cool. Great. So we have this instance up and running here. Whoops. Let's bring this guy into my desktop here. All right. So we have this instance. Let me go ahead and see if we can ping this instance. Right. So it's 172.23.203.70. Oh, come on. You know you want to work. And we could jump into the console of this as well. So let me go ahead and open up the console of this instance. So the instance is actually, wow, this is very slow. We've caught it at the boot up process, right? CentOS hasn't even come up yet, right? So this is nested virtualization for this demo. So we will have some performance deals there. But let me show you this application stack, right? So we deployed this environment. All this is up and running. We have a nice ready application, right? So the stack is built. And what it has created on the back end is this orchestration stack in heat, okay? So if we jump into this orchestration stack, and then jump over to the resources that it created. This thing created a ton of resources on the fly for us. Okay? You can look at some of the names here. We have floating IP addresses, network ports, guest customization scripts. We've created a network, a subnet, a router interfaces, a server, and a security group. So let's look at those objects, right? So here's that new Murano app. We showed you this list only had the external before. We now have a Murano application here. That Murano application has a subnet in it. So those are two objects we've created there. We then created a router and then wired that router into the external network here, as well as put it on the private network as well. Okay? So we've done that work through this application stack. And then we've created a security group, right? So we need to be able to communicate with this thing. If you ever deployed something in Amazon, then you try to SSH, and why can't I SSH to this, right? It's like, oh, I have to enable that security group. OpenStack has that same construct. So in order to make my life easy, I created an allow all rule because I'm insecure. So there's an allow all inbound rule here that from anywhere you can connect to that's applied to this system. And then again, floating IP address, very similar to an elastic IP. So that 172.23.203.70 IP address is actually being binatted to this 192.168.169.13 address, right? So all of this got created with that one application stack deployment. That deployment can be multiple virtual machines, multiple routers, anything you can think about building an OpenStack, you can do a one-click deployment with. So let's jump into this instance, and hey, it's up and running, it's pinging, thank you. So that's good. You can see it here in the console, the name has changed, right? It's now KVM stack-server1-GUID. We're in good shape there, and then I'm hoping that everything's in good shape here, and we should be able to hit it in a web browser. Oh, Apache's not up yet. So Apache's going to be on this in a minute. So it's still customizing. So we're in this thing now. And I should be able to cat out that guest customization log. And it's still doing yum, which is lovely. Looks like we're in the process of installing HTTPD right now. So HTTPD is almost installed. There we go. It finished doing the dependency check. Why am I doing this? Control A. KL minus F. This is the guest customization. We've caught it in the middle of this. And so it's installing, right? So let's jump back over to the Amazon environment just for the time being. Any questions on kind of what we're doing and some of this stuff?
Probably earlier than you, maybe we're going to cover this, but what about, you've got multi-tenancy obviously for your tenants. What about your management folks? So you're able to manage multiple systems, right? That's kind of the key thing. What if you've got multiple groups managing those systems internally already, and you want everybody to be able to manage, but only the things that they, can have access to? I mean, can you control that, or do you have to essentially take everybody who manages VMware and the people who manage something else and something else and throw them into one big pile of quote unquote admins? Yeah,
good question. So what we can do here with the multi-tenancy view is we have the ability to create quotas and whatnot per region, right? So if you look at this, a region is my AWS area or my vSphere area, right? So they're broken down already based on that. So then you can assign the quotas to this. So let's say the Tech Field Day quota administrative group, the Tech Field Day administrative group. Inside of Amazon, it has a 0 quota. Can't touch anything in Amazon, right? But in the main data center, right, they're allowed to have an unlimited quota. They can do everything. And you could set that up, and then you choose the users and the role that this user has inside of this tenant. So if you give them no access to that other region, then they won't be able to create any resources there, and then they are administrators of just this tenant, or a self-service user, which then wouldn't have any admin functionality. They couldn't see infrastructure at all. They can just consume this, right? So you can kind of slice and dice it that way. And there's a few different ways to go about doing that. We're in the process of creating a more in-depth RBAC rule where you can actually get much more fine-grained in doing that. We have this roles section here, and we really only have 2 roles. We have admins and self-service users. When that RBAC project is complete, you'll be able to create your own custom roles and apply those to be much more fine-grained. Did that answer your question?
Yeah. I mean, I'm just thinking of larger enterprises where you've actually got, silos within silos, right?
Right.
You might have an OpenStack group playing around with that sort of stuff. You've got people doing, VMware. You might have Citrix. You might have, whatever it may be, right?
Right.
So just because it's quote unquote systems or cloud or whatever term you want to use, it doesn't always suggest that it's the same group of 5, 10, 50 people that need that access.
Right.
So with a better RBAC, I think that would be very very useful.
Yeah, it's good feedback. Yeah, it's definitely on our roadmap. We've already started working on that. And we've gotten that from some of our larger customers that we need to be able to more fine-grain the permissions here. So that is something we're actively working on. So that system came up. It just took a while, right? So that's good. System's up, testing 1, 2, 3. So now we're going to, in order to jump into the HA side of things, he's going to kill the hypervisor on the back end that is running this machine, right? So he's going to be going over there and killing this thing. And we're going to then show what high availability looks like, right? So this virtual machine currently is running on the node. Wait, before you didn't kill it yet, did you?
I did.
You did. Lovely.
It's going to take some time, though. So
Let's see if we can catch it.
Yes.
Availability zones, enable. I didn't enable high availability.
okay.
So high availability needs to be enabled before you kill a host and expect high availability to work. Damn it. So
It might still work because I think we may have caught it in time. So
yeah, I think we might be able to get the agents on there. It should converge, and then it should find out that we have a host that's down that's in that group, and should still find that VM and power it on. Hopefully.
hopefully.
So we're enabling high availability now, and hopefully that will work. Damn, I have it written on this piece of paper right here that says enable VMHA, and I didn't do it. All right, fair enough. So let's jump into the Amazon side of things, right? So we spun up this Amazon instance, all the same stuff. Everything still says 0. Let's click the little refresh button. And hey, we have a VPC, we have an elastic IP, we have a network ACL, internet gateway. I feel like I'm in your way. And then a couple security groups. And if we jump into the EC2 side of things, again, we're going to have some more objects now, right? We have one running instance. It's up and running. It has this 52.8.150.113. So let's go and take a look at that here. Instances. And there it is, right? So it's representing the exact same information inside of the AWS console, right, that it is inside of our console. And then what we're going to do is, and you guys could play along if you want. This is a public IP address. See if the application ran. And it did. Right? So we got the exact same application deployed inside of Amazon, inside of our private data center, with the exact same code. We didn't change a line. We just swapped out a couple environment variables, and that's it. Right? So this is the power that other cloud brokers have promised for a long time, and they've delivered on, but they've delivered with their own proprietary APIs. And that's why we've open sourced this extensions of the OpenStack framework to include public clouds. So now there's no vendor lock-in because this is open source code. And it's an open API that isn't owned by one company, but by an open organization, the OpenStack Foundation. Right? So that's what we feel is a true cloud broker that you're not going to be locked into. So that's great. And And then we talked about our leasing functionality, right? Is there anybody in here that was a lab manager or vCloud Director admin at some point? No? Well, lab manager and vCloud Director had this functionality that essentially you can assign a lease to a machine. So when you build it, this machine's going to expire in 30 days, 60 days, 90 days, what have you, right? So it was part of the system, so admins can say, look, you can create VMs, but they're going to die after 30 days. And then you had the ability to go in there and say, I know it's been 28 days, I only have 2 days left, let me extend my lease. And you were allowed to extend it up to the max lease again, right? Another 30 days. So now you got your VM again, but it made you manage your resources and not just leave virtual machines sprawl everywhere. This is a huge problem that still exists today, and it's an even bigger problem on Amazon because you're being charged an arm and a leg when you just leave those things hanging out there, right? So we have this project called Moors, right? It has a REST API to it. It's open source. It's out on GitHub. But if you notice, when I spun up this VM inside of Amazon, it has a lease that it's going to expire tomorrow, right? So this VM will automatically get destroyed tomorrow. But this demo won't be fun if you guys sit here and watch this page until tomorrow. So we're going to edit our lease, and we're going to update the time that we want it to work. Now, we can't make it further than 24 hours because that's our minimum, our maximum time. But we could bring it to today. So let's go ahead and do that. Let's say today is the 2nd. My time clock is still in California time. So in California, it's about 9:00. We'll put 7 on there because I don't want this to update at the exact same time. Okay, so 9:07 today. We're going to update this lease. And then again, this is a public IP, so you guys can play along at home. And ping that, right? So now this instance is up and running right now. It has a lease that's going to expire in less than 2 minutes. And we can watch this, this unfold. You guys are a quiet bunch today. Is it me? You need to bring Madura back?
So for, I guess, a basic building block for me, this is all kind of new.
Sure.
The management that you're providing, it uses the native format of the underlying hypervisor. It's an AWS image, a VMware virtual machine, or KVM
Right.
virtual machine. It's not some special layer on top of a virtual machine, I guess.
That's correct, yeah. So in VMware, we actually have the VM templates that are there in VMware are images. So we can use those VM templates and clone those out, the same operations that VMware admins have done for 15 years now. And then with that, we have in KVM, they have what they call QCOW2 images, right? So it's kind of like a VMDK, but it's a QCOW2 image. And then Amazon has AMIs, right? So you can manage those and use your existing templates that you already have in all of these places, and we're just going to talk that language to know how to clone that template and do all of that. And we're using like VMware's API to do a clone operation, right? We're not reinventing the wheel there, but we're creating a unified way to access this. And it looks like we just killed that machine. Hey, it's dead. I love it. Love it when a plan comes together. So if I refresh here, I'll get back to that in a second. You can say, hey, it's actively deleting, right? Like it's being deleted right now. Moore's kicked this off and said, hey, your lease is up, you're done, which is lovely. But back to the API discussion, right? So we're taking these industry standard OpenStack APIs. Here's a list of them here. They're well documented. They're owned by the community. And you're consuming these, and transparently to the background, it's calling the vSphere SDK, or it's calling the AWS APIs, or it's calling libvirt on KVM, right? So there's drivers that are built to do all of this. So what we've done is built those same drivers that have existed for OpenStack to VMware in KVM, but we've built those for the public cloud. So that's kind of how we're doing this. So anything that calls on top of those services, right, like Moore's, right? We didn't plan for Moore's to be on top of Amazon because it was built before we had Amazon. But it worked out of the box because it's just calling the same APIs, right? So when you start building a larger ecosystem where services are dependent on one another, it'll just work. So that's cool. So that thing's down. I might have fudged the HA demo, which I do apologize for. I'm not sure if that's going to come back. Is it dead?
Yes.
It's dead. So, lesson to be learned, enable HA before you want to test HA. That's on me. I do apologize. We have a video that we could share later that shows how our HA works. But that's on me. Damn. Okay. So with that, I'm going to pass the ball back to Amrish, and he's going to jump into a little bit more. Any other questions?
Yeah, I think I probably can guess the answer, but what happens in a failure scenario with your control plane? I mean, does it fail,
Yeah.
fail kind of quote unquote open, everything just keeps running, you just can't manage it?
Yeah, that's a great question. Yeah. So this is probably one of the most common questions I get when we talk to a customer. What happens if I lose internet connectivity? What happens if your control plane goes down? What happens to my workloads? What happens to my management ability? What happens, right? So we built our control plane in what's called an eventually consistent manner. So anybody VMware admins here used vSphere, right? Does anybody remember vSphere before ESX before vCenter, the 2.5 days, right? So the best thing that VMware did when they came out with vCenter was when you created something in ESX, it showed up in vCenter. And when you created something in vCenter, it showed up in ESX. And when vCenter went down, you can go manage stuff in ESX, and then it synchronized changes when it came back together, right? So our team, our founders here, were part of building vCenter and ESX and making that work, and they were pretty disappointed when the design decision to not keep that same model into Lab Manager, vCloud Director, vRealized, kind of got broken. So they said, look, when we come and start our own company, we're going to do it the way we want to do it. And so we built this into our control plane so that if you could have it disconnected for days, and you could be managing things directly through vCenter or directly at the hypervisor level, and then we'll synchronize all those changes once it gets reestablished.
And with respect to the high availability system is actually running on-prem within the servers. So they know about each other. There is a bus that talks to each other. And when one host goes down, it can make the decision right there. So
Right.
It doesn't have to talk to the control plane.
Yeah.
Okay.
Just like VMware, where the HA runs, if vCenter goes down, and the host that goes down that's running vCenter goes down, HA still works, right? Because the brains for HA is inside the host, right? And by the way, the VM came up, and I know why. HA finally converged, and the host was marked as down, but the virtual machine was marked as active, and that's what we're using as a signal saying the host went down with the VM not going down gracefully. We found it, we powered it up. So that host actually came online, and if you look, it's now on a different host, right? It moved to a different host. It's now on host 3. It came back up. So I screwed it up, but our HA solution caught it and fixed my mistake. So that's lovely. So thank you for that.
I had to do some math in my head. Rough math. It cost at 2 or 3 jobs ago. It cost me $700,000 in development cost to create a deployment tool chain to deploy OpenStack programmatically. I mean, we could deploy from airplanes over Raspberry Pis, through Raspberry Pis on infrastructure, make magic happen. Cost me roughly $700,000 salary cost, so about $1 million total cost to be able to create something. And then, of course, the maintenance cost and all that's another 22% every year on that. What was the cost for, say, an 80 node cluster of what you showed?
So MSRP pricing, we charge per socket, right? So $1,500 per socket. So 1,500 times, assume 2 socket servers, 160 sockets there. I can't do math in my head that quickly, but probably close to 300K, I would assume.
Yep.
Okay.
Right? And then that includes the full lifecycle management, proactive troubleshooting, monitoring. So those bodies that you had doing that, I assume there's other operations teams around that that
Yes.
might not be included in that number. Maybe it is.
It was a development operations team plus
Yeah.
hundreds of engineers that used it. So in this case, there's a financial reason because we were able to use that tool chain to expand into other areas, which you just showed us how you could use the same tool chain to expand in other areas.
Yeah.
I think what you just showed me, by the way, and I don't work at the company anymore, so I can't sign a PO.
Yeah, no worries.
But what you just showed me is a way that by using new technology that you have contributed, your company has contributed to, created yourself, as well as open source platforms, that the total cost for me managing my OpenStack, customized OpenStack infrastructure would have been roughly a third.
And you touched upon a key point there. It's not just about setting up the OpenStack infrastructure, right? It's also about managing it after day 0 and day 1, where you have a repetitive cost that comes into managing those large teams and making sure that everything is up and running. That is something that's taken away by our SaaS managed platform as well.